Perfect. We got a healthy group here today.
Share the screen
as we start. Cheers. Supposed to be having coffee, but sick.
All right, well, just first off, thanks for everybody joining this morning. I saw Ray, Steve, a couple others, so appreciate you guys all joining. Today I have Russ, myself, and guest speaker Zach. We'll be talking about safety services from SICK, what we can offer, what we can help you guys with, how we break it down, so on and so forth.
Welcome to WebEx. Enter your access code or meeting number followed by pound.
Can we mute everybody?
Just a quick reminder, please, if you could mute your phone. We're getting some feedback.
Your entry 1355060.
Can we mute it on our end?
Let's see.
I know we can. I just don't always remember how.
Okay, let's try that. Okay, so you guys should be, if you've joined in any of our previous webinars, Russ, myself, Russ is out of Appleton. I'm out of Minneapolis. We do have a guest speaker with us for safety services, Zach Martens. So he's the product manager for safety services. He's based out of Minneapolis as well. And today we're going to break down the 6 steps to a safe machine. This is how SICK breaks it down into 6 steps. We'll talk about our main safety service offerings, how we can help you, what the benefit to you is. And so with that, we'll go ahead and get started. So starting off with an overview, we all know OSHA is the law of the land with safety, as far as safety goes. And the general duty clause is their clause saying that employers must provide a safe workplace. We go a little bit further. We like to point to ANSI B11.0, and since the risk assessment is really the building block for how we do safety at SICK, ANSI B11.0 says every new machine should have a risk assessment, and this really is the start of our safety service offerings. So next slide here, we'll go into the risk assessment. Zach, did you have anything to add here?
Yeah, so on that table, I think it's good to point out that, okay, there's the X, so when do you not need a risk assessment? And it's when you repair, rebuild, refurbish machinery. And something to point out about that is it says when utilizing comparable components. So that's on the component level, if it's not introducing a new risk, there's no, or new hazard, and then that would then induce the new risk, then you don't need a risk assessment. But you have to be careful with that note there. Even something as simple as like changing processing materials from a plastic to a metal, that can induce new hazards into your machine that you do need to take into account and need to be accounted for in the risk assessment. It may not be a new control method. It may just be an administrative method like wearing gloves, but it is something to note and be aware of.
Good. Yeah, I see the comparison there would be, the next point would be 3, which says, if you are rebuilding, refurbishing, and you're using different components, then yes, that would be the comparison where you should do a risk assessment. Good point, Zach. What about anytime you move a machine or relocate a machine?
Yeah, so taking into account the environment is part of a risk assessment. Different space allowance, different amount of life are all things that can change the risk assessment.
Okay, very good. So this slide really just shows how SICK breaks it down into 6 steps. That's our chart on the left. So of course, everything is based off of laws, regulations, and standards. And then we really start with step number 1, which is the risk assessment. And we go all the way down to machine validation and then operation of the machine. But the way SICK can help you with this is, we can do retrofit, product support, we can do training, product inspections, we can do consulting engineering. Zach, can you speak a little bit to the 6 steps to a safe machine?
Yeah, so that's a methodical method based off of standards that SICK uses to reduce risk and takes into account, starting with your laws, regulations, standards. You mentioned the OSHA General Duty Clause, right? That's your regulation, and then you have standards underneath that, like ANSI 11.0, ANSI 11.19, ISO 13849. Those types of standards then support that and tell you, okay, how do I provide a workplace free, safe from harm? So that's the starting point, and that informs everything that we do. So we take that into account throughout the entire process, and that it shows up at the top there as it's an overarching portion of the 6 steps. SICK offers services for that entire thing. I think we'll get into that throughout these slides.
Okay. Yeah, so we follow local, international standards. What if an end user plant has their own set of standards? Is that something that SICK is flexible to use in our safety service offerings too?
Yeah, so that's, if we're doing a risk assessment and there's certain particular, not standards, but or company standards that you want implemented in there, that's something that SICK is able to take into account.
Okay, very good. Yeah, it sounds like we're pretty flexible in how we're able to work with a customer there.
Yep, we want to be a partner.
Good. So then we talked really about the overarching, everything is based off of laws, regulations, and standards. And then we get into step 1, which is really, the launching point for our safety services. Everything that we recommend is based off of this risk assessment. Zach, what do we do when we come out and do a risk assessment on site? What are we looking for? How do we, interact with operators? Can you talk a little bit about that?
Yeah, so our team of engineers, when they come on site, or we can actually do this virtually now, we kind of took into account during COVID and traveling, okay, how can we do this? And we can actually do it virtually now with the customer being our seat. Per se, but as we get there and we're doing the risk assessment, it's really interviewing the operators and any user of the machine and kind of identifying those tasks that are pertinent to the machine, and we're also identifying all the hazards, and that's what makes up the risk, right? It's the task and hazard. We estimate the risk using a quantitative scale, and then we provide some risk reduction measures and a reduced risk out based off of those risk reduction measures. Important to note that we fully document everything, and it's not just okay, what's the most dangerous? It's actually every task and hazard pair is scored differently, and that allows when you get into your later designing your safety concept, you're able to differentiate each part and say, okay, what performance level am I going to need for this individual part to prevent over designing something to, say a performance level C for something that really doesn't need to be performance level B, and we can meet it with something that's going to be a little more cost effective.
I got one question for you, Zach. How would an OEM, would this be applicable for an OEM that's, they don't have a physical machine, they're designing a machine? How would the virtual risk assessment be something we can use in that case?
Yeah, so we want to be able to help out anyone early on in the process, right? It's easier and more cost effective to have the risk assessment done earlier in the process. Our team of engineers, they see all types of machines and they're designing these all the time, and they like to, whenever they are able to kind of guide where the safety system is going to be going early on in the process, it's helpful and definitely more cost effective in the long run. Sure. So when we're doing those virtual risk assessments where we don't actually have to be on site, what are we asking from the customer? Are we asking them for electrical drawings, mechanical drawings? Anything else that we need from them to be able to perform the risk assessment remotely?
Yeah, well, I think probably we do need those things. More specifically on the mechanical side of things, right? Layout drawings, that helps us understand where the hazards are going to be. Then we need the customer to actually be the legs for us, right? So it's almost like a FaceTime call where we're walking around the machine with them, interacting with them, and okay, can you show me this portion of the machine? Okay, let's talk to this person. So there is a little bit more reliance on them to get us around, but it is something that we're able to do remotely, and we've had really good success with it.
Sure. So you're like on the phone with the customer, asking them, okay, this task, how frequently do they have to do this task? And as long as we have that communication, we can then do our risk estimation and then provide them the risk assessment. Is that correct?
Exactly. Yep.
Perfect.
No, I have a quick note on this one, which is really interesting, and I think this the virtual risk assessment has become a very hot topic because we had a local customer here that wanted a risk assessment but didn't want to pay for travel and all of that, and they just had a small machine. We were able to do the risk assessment within a week because we scheduled the conference calls. We had a sales guy go out there, talk with the customer, and from my understanding, it was very inexpensive because there was just no travel. So, is that one of the big benefits of it?
Yep, that's another benefit that was coming out of something else, and we realized, oh wow, okay, yeah, there's no travel. We have teams throughout the United States and a pretty large service organization, but that's not always going to end up with someone in your backyard. So it is nice to be able to have that option.
Very good. So yeah, just to recap, the risk assessment is step number 1 of 6 steps to a safe machine. Boy, that's a tongue twister. But yeah, this is the building block for all the safety services that we can provide you. And on the last slide, we said, the standards say you should start with a risk assessment on all new machines, and then there's some other requirements too. But yeah, this would be step number 1. So I think we spent a little extra time on here, but that's because this is, we like to emphasize this is the first step.
If you do this well, the rest of it comes fairly easy.
Exactly.
Good.
Okay,
so following along on our chart here, we're in the middle steps now. So that's kind of our key as you're following along with Russ, myself, and Zach. On the left side there is the key. So we're in the middle steps here with that red outline. Go ahead, Russ.
Okay, yeah, so in the next step after you've done a risk assessment is to do a safety concept and a solution. So Zach, can you talk a little bit to the safety concept and how that entails, and then how it transitions into the installation services? And go ahead.
Yeah. So we follow the hierarchy of controls, right? Design it out. You control it out with engineering controls, and then administrative measures. And so you do an iterative process to reduce the risk to what is deemed acceptable in the eyes of the customer, right? So, ideally you don't have the hazard at all. Then, with engineering controls, okay, does this light curtain in front of the machine, is that allowing the proper access and to what the use case is? And then, okay, what are the PPEs? What are the lockout tagout requirements? Those types of questions. Those are all considered within our safety concept. Then you get it down into the details of, okay, how are we designing this to the correct performance level that was determined from the risk assessment. We do the tie-ins for, okay, this is where we need to go into the control system. This is where our equipment is going to go. Hardware is defined there. So if there's any type of hard guarding as well, right? So if there's a hole in the machine that needs to be covered up, that's fully defined in the safety concept. And lastly, Yeah, so I already talked about the PPE as well. So it kind of goes a holistic approach to getting the design, and then we actually within that are showing, okay, based off of this and doing methods, we take care of the functional safety side of it to say, okay, this will have the performance to meet the performance level B or performance level D, depending on the machine.
So where the rubber meets the road here, Zach, this is where we mark up the drawings, tell you where to mount the light curtains, what light curtain needs to be used, what mat needs to be used, that type of stuff. So is this the engineering plan, physical plan?
Exactly. It's the full engineering documentation behind a safety solution or any safety project.
Okay. And then from there we can also do the installation. And then my question to you, Zach, is can a customer buy the risk assessment but not the safety concept and say, I've got it from here, or can they buy the risk assessment and the safety concept and say, I want to install it myself, or do we have to do the installation?
Yeah, that's a great question. We want to be a partner, right? And we understand that our customers have different competences, right? They might be super comfortable doing the design and they have all that competence there. So we want to let them do that portion, right? Okay, we'll take the risk assessment, we'll do the installation. We have the guys who do that all the time. Or maybe it's, hey, we already have a risk assessment, we're not really sure what to do. Okay, we can take it from there. So it's really just a give and take on what our strengths are, and we want to work together for what makes sense for each person.
That's interesting. So if a customer has their own risk assessment, because a lot of them have their own format, we're able to work with their risk assessment so that, and then help them create the concept and installation.
Yeah, we do look for it to be a task-based risk assessment like we talked about. So breaking down each task and hazard pair, we like to see that so we're not over-designing systems. It can be quite cumbersome, designing an entire system to a called out performance level D, and where that becomes really cumbersome. So it's something we want to take a look at before we get into the project, but it's definitely doable, and we do it quite frequently.
Okay. Perfect. So on this, you can see that we're moving right along the 6 steps. So we're into the 5th and 6th step here, validation services. So once again, Zach, if you talk to what are we doing in the validation? And I've also heard the term verification. What's the difference, and what's happening at this stage of the process?
Yeah, so that's a great question, and I think it gets missed a lot within even our 6 steps. So verification is done throughout our entire process. Verification is making sure that you built the right solution, right? Is it built per the design? Excuse me. Validation is, does this design actually meet the intent? So according to our risk assessment, is this actually reducing the risk? And you have to have validation and verification to fully vet out your solution. So SICK does do validation services, and like I was saying there, verification is fully built into the process. We use stuff such as the 4 Eyes principle on reviews of documentation. As we go through some of the functional safety aspects, we're actually doing verification to make sure, do the quantitative analysis of our safety functions to say, okay, is this actually meeting the performance level that we specified? But within validation, we're really checking, does it meet the intent of that risk assessment? Is the risk actually being reduced in the manner that was set out in the design, or not by the design, but in the risk assessment? So we have that.
Okay, so during the validation process, is this when the technician comes out and pushes the e-stop and says, yep, the machine stopped, and pushes the reset and the restart? Are they checking all the physical, make sure the program is working correctly? Is that what this is all about?
Yep. Yeah. So that's part of it, and there's also the introducing of faults, right? So we want to make sure that certain fault points that our engineering team actually defines before going out to site. Say, hey, we need to check this, make sure things are functioning in the way that we intended. We need to, they'll be checking the field. So if there's a safety scanner, making sure that it has the right height, mounting height, it has the correct resolution, those types of things, and the fields are set properly. So those all come down within the validation.
Okay. I had one quick question, back one slide, if you could, Jake. Under the engineering controls and administration, or mainly under the engineering controls, does SICK actually build the panels, or are we relying on the customer to do that? Say somebody's moving a palletizer from, Georgia to Atlanta, and they want to upgrade it. Who builds the panels and does the program? Is that done by SICK as well?
Yeah, so we definitely do that. We have our actually UL certified panel shop that most of our solutions actually will utilize a panel that ties into the customer panel. That way we can have all the safety components all in one place. Makes it easy to troubleshoot and also easy to install.
Okay, perfect. Thank you. Next slide. And okay, then what other services? So under there we have other services that we can that are complementary to the 6 steps. Do you run into these very often, or can you talk to them at all, Zach?
Yeah, it's one of the, I think, the more popular things that we have are our training courses. We have a dedicated team of engineers and trainers that actually will do any sort of training courses. We have everything from just a basic, what is a risk assessment, all the way into functional safety. For people who are familiar and use Systema, we have Systema training courses. And then even down to our products, right? If they want to know more about how to fully configure a safety scanner, we have courses just designed around that and making sure that the customer's team is actually comfortable with using that product. Stop time measurement is one that we do, and it's actually part of our 6 steps when we're doing the safety concept, taking measurements of the stop time of certain hazards, and with whatever equipment, and that goes into our design normally, but it is something that we do offer for if a customer doesn't want to buy the stop time device, which is understandably so, and keep that up to certification. We can actually come out and do that. Along with that is inspections, and the inspection was really driven originally by the European market as something that's required by the machinery directive, but it is something that's pretty useful here. If a customer is just looking to understand where, understand if, okay, did I install this correctly? It's actually done on the device, and it's not something that it can be very useful if they just want a quick check of the machine without doing a full risk assessment.
Hey, Russ, Zach, I have a question too. So what if the customer knows that they have a bunch of machines that need risk assessments, so they want to do risk assessments? How do they know where to start?
Yeah,
do we have an offering for that too?
Yeah, it's actually something new that we got started this year. It's called our Machine Safety Prioritization Service. And what that's doing is it's taking a snapshot of where each machine in a facility or within the organization is at. It quantitatively takes, okay, this is what my overall kind of a high risk, and then how do we reduce that risk based off of what's on the machine. It's not in depth as a risk assessment by any means, but it kind of gives a snapshot of where equipment is currently sitting, so you can kind of tackle the things that might not have as much guarding on them today, because we understand that there's going to be a priority, and a lot of times it's a multi-year process for facilities to upgrade.
Okay. So we can go through their plant or a live multiple lines in their plant and say, here's your machine risk. Do we give them a number, or how does that work? And then based off that number, the customer can decide, okay, we want to do these machines first. Is that how it works?
Yeah, so each machine gets a score in the end, and the nice thing is it's done. It's on the same scale. So if it's multiple facilities, multiple people doing this, you're going to be able to compare facilities actually, not just within one facility, but if there's any type of corporate initiative to going across multiple sites, you're able to compare.
Nice. Great question, Jake.
Good. Anything else on this slide, guys?
I don't think so. I think you did a great job, Zach. So at the end of the day, what is the deliverable? So what this slide is trying to show, and there's a lot of words on here, is in a risk assessment, what do you get at the end of the day? I have some risk assessments. If anybody wants to stick around afterwards, I've got one. I'll pop up a real one. But this is the heart of a risk assessment. So you got your ID, 1 and 2. You could have 50 different items. We go into the user task, because remember, we're doing a task hazard pair. So you got the task and the hazard combined. And Zach, in my understanding is we do that so that we're not over engineering. It's actually a means of saving customers money, because is it my understanding that we then apply the safety measure to that task and hazard instead of applying it to the whole machine, which may not need it?
Correct. So if you even take in the first example there, it was a risk in of 1. Mainly, the only difference is the occurrence. So we didn't add any engineered controls there to reduce risk. And typically, the engineered controls are going to be the ones that add the cost at the end of the day and complexity in design. So by breaking this out, you're actually able to reduce risk without getting too involved and show in a way, okay, this is exactly how we did this, and we have a table that shows, okay, what reduces what risk based off of your portions of risk, as your severity, exposure, avoidance, occurrence.
Right. Okay. So you use your task, your hazard, and then you look at the severity. How much is somebody going to get hurt? The exposure. How often is it happening, and can they avoid it? And then the occurrence. So it's how often and how long. And then you give it a risk, which also gives it a performance level. And then we go in and tell you exactly what you need to do, all the way down to administrative measures, et cetera. And then at the end, it shows what your risk level will be out. And then, is that the way these work?
Exactly.
Interesting. Yeah.
So I think the big thing here that I'm seeing is that we're providing the risk reduction recommendations right from step 1 in the risk assessments. I think seems like there's a lot of value in just starting with the risk assessment here, because we're already giving you reduction methods right from step 1. Is that correct?
Right. From this, you could actually take it.
Yep, exactly. And depending on the comfort, that might be all you need. If you understand, okay, how is this properly going to be integrated, it shows kind of an overview of what the planned method would be to reduce risk. And then it doesn't go necessarily into the obviously the detailed engineering and tie-in and device specification, but it is an overview of what the solution would look like.
Exactly.
Excellent.
And then so our safety concept and the engineering plan would be based off of these recommendations. Is that how we would do it?
Exactly. Yep. This is the first thing that they look at, and they okay, this is where we're going to start and how we're going to plan our design.
I know we're running low on the end of our time, but I wanted to ask one last little question that comes up every once in a while in my area. Some of my customers like to use third-party devices, non-SIC devices, or their plant may be specified say Rockwell just for fun. Do we have any issue working with the other vendors?
No, we don't, and that's something we run into pretty frequently, where maybe a device is specified for a certain facility. We're willing to work with that, and we understand that you have those needs. And within our safety solution, we're using third-party components all the time to meet certain aspects that SICK doesn't have an offering for. So it is something that we are definitely comfortable with doing.
Great. So I guess the last thing would be, how does the customer get started if they want to engage us in their process? Where would they begin?
Well, I would start with talking to someone in our sales team on kind of where, kind of what they're looking for. We have a specialized team that deals with the kind of understanding what the safety needs are, and we can get them involved as well. As I know you and Jake also do some of that to understand the needs, and then if we can learn more on how we can work together.
Perfect. I think that was all the questions that I had. Everybody that's on this conference, I'll be sending out to the person who invited you. I'll send you samples of the risk assessment, safety concept, and validation reports, just so you see, because you can't just do these steps. You have to document these steps. So what you'll get is samples of what a report might look like as a follow-up to this webinar. So with that, do you have anything, Jake?
No, I think that's a great wrap-up, guys. Yeah, those last slides will hit really on how we get this process started.
We want to open up to any questions of anybody who wants to stick around and unmute.
Yeah, let's open up to questions now. I see we still have a good crowd here. So we'll stay on for the next 10 minutes here. If anyone has any questions, they can come off of mute now. So Jeremy, you sent in a chat question. If you still had that, we could try to answer that too.
Yeah, just a quick question. I have had OEMs ask this question in the past. Are we able to CE certify a machine that they built has to ship out?
That is not something that we're actively doing. It's something we're looking into, but not something that we're doing right now. Well, part of that though is actually documenting all the steps that we talked about, and that is a big part of getting the CE marks. So that is something that we are able to help out with.
So we can't supply the sticker though. It says it's CE certified.
Correct.
Yeah. Okay.
Any other questions out there?
Yeah, good question, Jeremy.
Okay, if we have no other questions, I vote to adjourn.
Sounds good. I appreciate you guys having me on today.
Yeah.
Thank you, Zach, and we appreciate all our participants.
Thanks, guys.
Yeah, thank you for the presentation.
Thanks for everybody joining.